Ladies and gentlemen, today we're going to talk about solving proportions. This is Pre-Algebra lesson 4-3, and it's called solving proportions. I'm going to start with problem number 5. This is going to be our first example. And let me go ahead and zoom in here so you can see it up close. This is not going to be off your homework. This is going to be similar to the problems you'll see on your homework. They give you two fractions, and these are actually ratios. 1/4, or 1:4, as we would call it, and 2/10. And the question that they're posing to you in looking at this is, do they form a proportion? So I'm going to go ahead and write that question here. We can't answer that question yet. That is ultimately what we have to answer to kind of answer the question, but we can't answer it directly. We have to look at it a little differently. You should know that ratios are proportional if they're equal to each other. So one of the things that we do is we actually set up what is called a mathematical test. Okay, mathematical tests are actually how computer programming works. Okay, either yes or no is how it works. And then the fundamental, this all goes all the way right down to like binary. Either it's on or it's off, ones and zeros. Okay, so a mathematical test is something where we say it is or it is not. It is or it is not a proportion. And so in order to kind of look at that, we will have to say they are or they are not equal. Okay, this is basically like a true or false type problem. So the way I would set this up, I would say, okay, 1/4 is equal to or is not equal to 2/10, true or false. Okay, that's kind of how I would go about solving this. And so I would look at it and I would say, are they equal? Well, one of the things you can do to try to figure this out is you can simplify one side or the other if it's necessary. And in this particular case, it is. Okay, 2/10 can be simplified. Does anyone know what can be simplified to, Mason? Yeah, absolutely. Can definitely be simplified to 1/5. So we have 1/4 equal to 1/5. True or false? What do you think? Yeah, it's definitely false. Okay, it's false. It's definitely not equal to each other. So now that we've identified that they are not equal to each other, do they form a proportion? The answer is no. Okay? The answer is no. However, let's look at a problem where they may form a proportion. We'll look at a second example here. Number 7 in your text is 7/6 or 7/26 and 28/24. Why am I saying it 7/26 and 28/24? Yeah, David? Okay, the top number is bigger, sure. And these are also not just fractions, they are what, Reese? They're ratios. And when we speak about ratios, we like to identify them 7/26 and 28/24 so that we get it in our heads that we're dealing with a comparison. Okay? Remember, these are ratios. And therefore, we are making comparisons. You guys will actually do this. I think it's a couple sections ahead here. Yep. Like right around page 185, where you're going to actually be making comparisons between triangles and rectangles and circles and things like that. So you're actually going to take this idea of making proportions and comparing proportions and solving proportions and ratios. You're going to be taking this to the next level in the next several sections. So this idea of understanding that they're a comparison is pretty important. Okay, so I don't want that to kind of be slip out of the way. We're not actually setting fractions equal to each other. We're setting ratios equal to each other and testing them to see if they are indeed equal or they are not. Okay. So this time, again, we're going to make up our mathematical test. We are going to say 7 to 6 equal to 28 to 24. Is this true or false? Okay. Can one of them be simplified? Yeah, which one? Yeah, 28 to 24. What can I divide top and bottom by to simplify it? David? I can divide top and bottom by 4. Yeah. So if I were to do this, I'm going to go ahead and even move it over a little bit so that I'm going to consolidate it a little bit. If I divide top and bottom by 4, what do I get? Yeah, Kennedy. Yeah, I do get 7 over 6. And because that then is equivalent to the other side of the test or the equation that I've created here, we would say that this is indeed a true statement. And therefore, do they make a proportion? Yes, they do. Yes, there is a proportion here. Liam.
So if they're equal, like how they are in that one,
Mm-hmm.
will it always be like the first ratio, like if you multiply it by a number, will it equal like 7 times 3 is 28, and it takes proportion. So will it always be like that?
Yes, it will.
Okay.
Yes, it will. Yep. That's a great question. If you can multiply one fraction by the same number, top and bottom, and get the second fraction, then you do indeed have a proportion. Yes, that is a great. And we would say these are proportional. One is 4 times larger than the other. Okay? That is the proportion. One is 4 times larger. Over here, there was no proportion because I couldn't multiply the top and bottom by the same number. Does anyone know how architects might use this idea? Does anyone know how an architect might use the idea of a ratio? Reese?
They might have to make a scale model for a museum.
Yeah, they might have to make a scale model. Has anyone ever seen or made like a model of something? You've made like a little model car, or like for instance, right here I have my Volkswagen. Okay, this Volkswagen is a scale model, die-cast model of one of the first edition revamped Volkswagen Beetles. Okay, it's a scale model. This is literally to scale, which means every piece is proportional to the real car. If I brought the real car in and I made comparisons between like hood length and hood width, it would be proportional to the real hood length and hood width of the real Volkswagen Beetle. This is to proportion in every single way. Okay, that's why it looks like a real Volkswagen Beetle. If it wasn't to proportion, it might look fatter, it might look wider, it might look taller, it might look skinnier, it might look like a clown car, it might look a little weird. Okay, the way that cartoons portray the real world is that they skew real proportions. So like for instance, in like old-fashioned Looney Tunes, they would take a car that was modeled after a Volkswagen Beetle and they'd squish it so it was really skinny, and then they'd have like 100 characters climb out of it. Okay, so they did not draw their cars to proportion or to proper proportions. Okay, so this is proportional in every single way to the real car, right down to the interior displays, numbers, and everything like that. All right. Now, there is a second type of problem you're going to see in this lesson. Okay, and I'm going to go ahead and do that over here in some open space. This is going to be this is going to be problem number 13, example 3. And this is going to ask us to solve the proportion. Okay, I'm going to go ahead and draw a line here to separate it. So we're trying to solve the proportion. 2/9 equal to 10 over a. All right, I've given you a statement. In this particular situation, they're not asking you to identify whether it's true or false. They're not asking you that at all. What they're asking you is to make it true. And the only way to make it true is that you have to take this placeholder a, aka a variable. It's a placeholder. You have to find the number that can take its place that will make the statement true. So I have 2/9 and it equals 10 over something. That something is what you need to find. So in this particular case, I'm going to encourage you to ask yourself this question. What do I multiply the first fraction by to get the second, or, oh, my bad. What do I multiply the first ratio by to get the second ratio? Kennedy? Okay, 5. We can see that if you multiply 2 by 5, you get 10. What I do to the top, I must do to the, bottom, right? It's the golden rule of mathematics, one of them. There are several. So if I multiply the bottom by 5, what do I get? Yeah, and so this number here must equal 45. That is the number that will make that statement true. I would like to say that it's always going to be as simple as multiplying by a whole number. Unfortunately, it's not always as simple as multiplying by a whole number. In this particular case, Kennedy said, oh yeah, I see that 2 to 5, or 2 to 10, you have to multiply by 5. Easy enough. And yeah, it is. That was great. But sometimes we're going to get problems that you're not going to be able to multiply by a whole number. And so let's take a look at an example like this. 19 is a great example of this. This is the last example I have for you, ladies and gentlemen, today, and then I will give you your assignment. 19. You have x over 63 equals 9 over 14. Well, this problem is a little bit more backwards than any of the problems we've looked at so far. Here's how it's different. First of all, the larger numbers are on the left-hand side instead of the right. And that's okay when you're comparing ratios. But just know that we've looked at so far all the smaller numbers being on the left. So in this way, it's a little different. The second thing we have to look at is that 63 and 14, there's no easy comparison there. 14, there's no whole number you can multiply 14 by that will make it 63. So now we're working with decimals, okay? So we have to find what we can multiply 9 to 14 by to get something up here over 63. We can make, hold on, I'm sure some of you have already figured this out, okay? You can know this, however. Is x going to be greater than or less than 63? It's going to be less than 63 because 9 is less than 14. So at least we have a parameter. We know it's going to be somewhere between probably 1 and 63. We actually probably know it's going to be greater than what number? 9. It's got to be larger than 9 since 63 is larger than 14. Okay? And 63 is larger than double or even triple 14. So we know that whatever x is, it's got to be larger than triple 9. So it's going to be somewhere between 27 and 63. Okay? It's got to be somewhere between those two numbers. The reason that we would look at it that way is because sometimes you might make a mathematical error. You might plug in the wrong number, and you get an answer, and then you have to ask yourself, does it make sense? Okay? By looking at it and saying, I know it's probably somewhere between 27 and 63, that gives you a range. And if your answer does not fall within that range, you know, or you can tell yourself, I think I might have made a mistake. And you can go back and double check it. Okay? So sometimes asking ourselves, does it make sense, can be one of the greatest things we do in a math problem. All right. Now, in a problem like this where you have an equal sign separating two ratios, which look like fractions, you will do something called finding the cross product, or, as you probably have heard it called, what? Cross multiplying. Okay? So to solve this, we are going to cross multiply. All right. So I'm going to start by multiplying my 9 and my 63. I'm not going to make it smaller yet. You don't want to confuse this with cross simplifying. Okay? You do not want to confuse this with cross simplifying. However, we will do it two ways. We will do it simplified and unsimplified, and we'll see if we get the same answer. Okay, and then you can know whether it'll work or not. So 63 times 9 equals 4. Oh, does it? Hang on one second. 14 times x, and 63 times 9 is what, Casey? 567 equals 14 times x. What do I have to do to get x by itself, Jaden? Yeah, the opposite operation, or the okay? The opposite operation, the okay? So we're going to divide both sides by 14. What happens to my 14s on the right-hand side? Yeah. Yeah. Absolutely they do. They go away because if you have the same number in top and bottom, it really becomes 1. So we don't really need to write it anymore. We call this canceling, but it doesn't really go away. It just turns into a 1. All right, and 567 divided by 14 is 40.5. Okay, yes, you could have divided 63 by 14, then multiplied that by 9, and you would have gotten x. We call that circular reasoning, sort of. And the way that, what I mean by that is, let me go over to the next page. X over 63 equals 9 over 14. You did this, and correct me if I'm wrong, but you took 63 and divided it by 14, moving in this direction. You found that that equaled 4.5. You then took 4.5 and you plugged it in over here, and you multiplied by 4.5, and you got 40.5, and then that gave you x. Okay, and so basically we worked in this direction. It's kind of like a circular solving method. It does work. I will give you a word of warning here, in that in some cases you are more likely to make an error in this way than doing it through cross multiplication. And the reason is that this involves mostly mental math, whereas, or at least multi-step math, whereas the other way, we are writing down a system of solving an equation. I will let you pick which method works best for you. Now, the one other thing that was brought up, okay, was this. Can you simplify beforehand? X over 63 equals 9 over 14. Well, we do know that what goes into 63 and 9? 9. Okay, we do know that. Okay, so this would be what? 9 goes into 63 how many times? 7. And then if we were to cross this out and make it a 1, because 9 goes into 9 one time, okay, then we have x over 7 equals 1 over 14. I'm going to cross multiply this just so that I know that the math will be good, and I'm going to see if I get the right answer. If the simplifying is appropriate, if it's allowed, we should get the right answer. However, the simplifying may have changed the problem such that it could change the answer, and if it changes the answer, then that means that simplifying is a very bad idea. It's illegal, okay? So let's see if it did. We get 14x equals 7 through cross multiplication. Okay, if I divide both sides by 14, I get x equals what? 1/2. Is that 40.5? No. So here's what I can tell you. Do not simplify across the equal sign.
So like it'll never work?
Nope.
Or sometimes?
Nope, it will never work. The only time you can simplify is if you are on the same side of an equal sign. I will give you one example of this, but I do not want to go I don't want to go into this in too much depth so as you get confused. If you had 2 fourths times 1/2 equals 6. Or, well, I won't do 6 because it doesn't equal that. But what I will do is let's say equals x. Okay? Notice that the 2/4 and the 1/2 are on the same side as the equal sign. In this way, we could then simplify the 2 and the 2 into 1 and 1 because 2 goes into 2 one time. Okay? And so then that would be okay. You cannot simplify. Do not do DND, okay, across the equal sign. Do not simplify across the equal sign. Does that make sense? You will change your answer and it will be wrong. I'm glad that we talked that one through. I'm glad you asked that question. It was fantastic. It was fantastic.